Let us look at the Cobb-Douglas utility function and few issues related to the Cobb-Douglas utility function. For example, how do you draw an indifference curve for the Cobb-Douglas utility function? How do you derive the demand function for this utility function? Is the good which you have got, is that an ordinary good or it is a given good? How do you draw the angel curve for the Cobb-Douglas utility function? Uh, what is an income offer curve for that? Is the good which you have got, is that a normal good or an inferior good? Is that a substitute or a complement? How do you find out the own price elasticity, cross price elasticity, and income elasticity for a Cobb-Douglas utility function? So, and we'll do it for the other general utility functions as well. So let us just start with this. So this is the way your Cobb-Douglas utility function is written as u is equal to xy. The general form is x to the power alpha, y to the power beta beta both greater than 0. We're taking the one form for that, which is u equals to xy. So when you want to draw an indifference curve for this, what is it that you will have to do? You will have to uh, use some arbit utility. Arbit utility as in you will fix some utility, because along an indifference curve, all points are going to give you the same utility. So you'll fix up some utilities, say u bar is equal to 4. And we'll find out such points of x and y which is going to give me u bar equals to 4 according to this function. So it is 4 1 1 4 16 1 by 4 1 by 4 16 2 2. Well, minus 4 minus 1, that could also have given you 4. Minus 16 minus 1 by 4 could have also given you 4. But those could not be taken. The reason being, your goods should be belonging to the positive orthant of the real plane. So if capital X is the consumption set, it is assumed that it is belonging to Rn plus. Plus means, I mean, it is flowing from including 0 to plus infinity. So you can have 0 of a good, you can have positive units of the good, but you cannot have negative of the good, right? So capital X, which is your consumption set, it should belong to Rn plus. N is the nth dimension commodity vector. So for example, so this is just the 2 dimension out here, but you can also have x1, x2, x3 into and so on to xn. So what do you do? That how do you derive the indifference curve for this? Right. So you pick up all these points, right? And you will have a function like this. U bar equals to xy. This is 4 equals to xy. You can just plug in these points and you'll be having all this. Well, how do you find out where exactly you're going to consume? So supposedly, if this would have been your budget line, this green line would have been your budget line. And then you ask yourself that what is the highest indifference curve you can draw? Because this budget line is given to you. Supposedly this budget is telling you that you have 100 rupees as an income. Now you can spend. So what is it that you will be doing? You can probably just ask yourself, is this the highest indifference curve given this budget line? No, I mean, I can go still further till this point. So this is the tangency point out here between the indifference curve and the budget line. So I'm doing a very cookbook procedure right now, which is a simple Lagrangian technique in order to find out how do you get the optimals. But this could be used only for the differentiable functions and could only be used for the equality constraint problem. So your m equals to p1x plus p2y. That is your budget constraint. So what you're doing here is this, that you are maximizing u equals to xy. That is the utility maximization, subject to P1x plus P2y equals to m, right? That's the constraint. So you want to maximize this utility subject to this constraint. So this constraint is given to you. Now you need to maximize this utility, right? So we'll use the Lagrangian technique. I'll give you a few examples of the Lagrange. I mean, when it could be used in something, but not here. Just because we'll be completely off the track then. In that case, but I'm sure that you will understand this. So what you have is that you have this objective function and you have this constraint. This lambda is the Lagrange multiplier. Just you have to remember this, that how many partial derivatives you need to find out. One for each variable and one for the constraint. So it is del L by del X is y minus lambda P1 equals to 0. Del L by del Y is X minus lambda P2 equals to 0. And del L by del lambda is M minus P1x minus P2y equals to 0. There's a complete theory behind this Lagrange multiplier. We are just following this just to tell you how it is done first. So before you get into the theory of Lagrange multipliers or what is this Lagrangian technique, what exactly it is trying to find out. Of course, it is trying to find out that it is going to give you the tangency point between your objective function and the constraint. And then you will be substituting whatever values you're going to get for the get for these tangency point back into the function to find out whether it is giving you a max or a min. So right now, just the procedure so that you understand what's going on. So it is, you divide first by second, beta. You divide first by second and you will be getting y by x equals to P1 by P2. Y equals to x P1 by P2. And I can substitute this back into the constraint, right? So my constraint is what? M minus P1x minus P2y. In place of y, I can write what? X P1 by P2, which you have just. So this P2 will get cancelled out. M minus 2P1x equals to 0. So this is m by 2p1. So x star is m by 2p1. And if we'll substitute this x star back into this y beta, which is m by 2p1. So it is m by 2p2. So x star, y star are m by 2p1 and m by 2p2. These are your demand functions. So how much, what are the things which you have already found out? You have found out what is an indifference curve for this. You have found out what is the demand function for this. Let's find out whether this good is an ordinary good or the given good. Well, what is an ordinary good? So ordinary good would be the one, which is going to follow law of demand, in the sense that in case if the price is going to increase, demand is going to fall and vice versa. So let's just check that. Ordinary good. Basically, or if price increases, then demand falls. Right, beta? So basically what you are trying to say is this. So del x by del px is less than 0 and vice versa, of course. So if price falls, demand increases. You may or may not want to write this. So then you have, this is what an ordinary good is. What about your the another good, which is given good? Given good is an exception to the law of demand. So in case of the price is going to increase, demand is going to increase. If price increases, demand increases. So let us just check that. Well, you already have x star as m by 2px. Let us just check whether x is an ordinary good or it is the given good. So del x star by del px is what? Minus n upon 2 px square. This is less than 0, right? So as your price is increasing, then demand is decreasing, right? Demand is decreasing because m2 px, they're all positive. Because of this minus sign, this becomes negative. So x is an ordinary good. X is an ordinary good. Okay. What else? Then you have whether this is the normal good or it is an inferior good. Let us just check that as well. So normal good would be 1 in case if your income is going to increase, then the demand for such a good is going to increase. So inferior good or normal good first of all. Normal good. There is a positive relationship between income and the quantity demanded. So in case if the income is going to increase, demand for such a good is going to increase. If income is going to fall, demand for such a good is going to fall. So if income increases, demand for such a good increases. What about inferior good? If income increases, demand for such a good falls. That is what an inferior good is. Right? So there is a negative relationship between the income and the quantity demanded for an inferior good. Well, let us just check whether we have x as being the normal good or an inferior good. So we have what? We already have x star as m by 2p1. So del x star by del m is going to be what? 1 upon 2p1, which is greater than 0. So as your income is increasing, demand for such a good is increasing. Hence, x is the normal good. Hence, x is the normal good, right? Okay. What about the, you can also think about, I mean, how do you write the income offer curve or the angel curve out here? So let's first of all write how do you find out the income offer curves? It's very simple, right? So, for example, you have this guy with you. So, this is drawn in XY space. Initially, this was the income. you were consuming out here. Let me call this as point E1. And now your income increases. So when your income is going to increase, budget line is going to shift outwards. Well, if income is going to increase and the budget line is going to shift outwards, and this is going to be the position of your indifference curve and hence the equilibrium. Supposedly, if both x and y are normal goods, so as your income is going to increase, you're consuming more of both of them. So you are going to move from U1 to U2 and the equilibrium is going to change from E1 to E2. Well, if you join these points, then what happens is, what you're going to get is the income offer curve. Join the equilibrium points, right? Join the equilibrium points. So what is the income offer curve? It is the locus of equilibrium points in xy space as income changes, right? So you call this as an income offer curve, or you call this as an income expansion path, whichever word you want to use. Right, beta? Now you have already derived this. You have already derived x star as m by 2 p1. So I can write m as 2 p1 x star. You've also derived y star as m by 2 p2. So I can write m as 2 p2 y star. Now I can equate these two m's, the same. So it is 2 p1 x star equals to 2 p2 y star. Right, beta? So this thing is going to get cancelled and you will have what? P1 upon P2 equals to this y star upon x star. So what is your x star? Basically, or you can just write your y star as x star P1 by P2, right? Or x star as P2 by P1 y star. So this is the expression of the income expansion path. This guy is an expression for the income expansion path. Now what else? Then you have something which is called an angel curve. But mind you, income of a curve is drawn in xy space. Angel curve. So what would be an angel curve? Now angel curve is that as your income is increasing, how is the demand for the commodity is changing? That is what the angel curve is, right? So, and it is drawn for a given level of price. So how do you write this? So it is showing you the relationship between the income and the quantity demanded for a given level of price. Right? Income and quantity demanded for a given price level, right? Well, you've already derived x star is m by 2p1, right? You've already derived x star is m by 2p1. Well, this is the expression of the angel curve for a given level of price. P1 is given to you. So this is just the relationship between, right? So this is an expression of the angel curve for a given price level. For a given price level, right? Well, I can also write this as m equals to 2p1 x star, and then I can write this as dm equals to 2. So for a given level of price, so it will be 2p1 dx star, right, beta? So dm by dx star, that is going to be the slope, is 2p1, that is greater than 0, right? So you have the positive slope for this. You have the positive slope for this. Well, you have income out here and you have this thing out here, commodity demand out here. And this is going to be your angel curve for this commodity, for X commodity, for the Cobb-Douglas utility function. This is a positively sloped function. So that's a slope of the curve, the variable on the x or variable on the vertical axis upon the variable on the x-axis. You with me? Okay, what else we have? Okay, we have derived we have defined what is an ordinary good, what is the angel curve, this thing, in substitutes and complements. Okay. So how do we know whether the good is a substitute or a complement? So we'll rather say it is gross substitute or gross complements. Gross substitutes or gross complements. So when you say that two goods are gross substitutes, so for example, there is Coke and Pepsi. If the price of Coke is going to increase, people will think that why should I be buying Coke? For me, both Coke and Pepsi are substitutes in a way. So in case the price of Coke has increased, I should reduce my demand for the Coke, and I can fill up my utility by consuming more of Pepsi. So because the price of the Coke has increased, the demand for Pepsi has increased. So then Coke and Pepsi have become substitutes of each other. So two goods. X and Y are gross substitutes when del x by del px is sorry, not del x by del px, when the demand for x and the price of y. So in case of the price of y is going to increase, demand for y is going to fall and the demand for x is going to increase. This is positive. And they are gross complements. For example, paper and ink. So if the price of the ink is going to increase, demand for ink is going to fall. But you will also think that why? I mean, since the price of the ink has increased, I mean, on what I should be writing also, why I would need paper as well. So I'll be demanding less of paper. So when the price of ink has increased, demand for ink has fallen, and at the same time, demand for paper also has fallen. So the price for paper has not changed at all. It is just the price of the complementary good has increased, and because of this the demand for this good is falling. When are the two goods cross complements? When del x by del py is less than 0. You with me? So let us look at our thing out here, which we have just derived. So x star is m by 2px. Now there is no question of this being a substitute or a complement because there is no py out here. They are not related. Del x star by del py is equal to 0. Del x star by del py is equal to 0. So, and similarly for even y star, you can just think of like this. So it is m upon 2py del y star by del px equals to 0. So it means that x and y are independent, or you can say x and y are neither gross substitutes nor gross complements. Okay, what else is left? So we have talked about substitute complements also, and then you have own price elasticity of demand, income elasticity of demand, and cross price elasticity of demand. Well, how do you write the own price elasticity of demand? Own price elasticity of demand. So the percentage change in the quantity demanded for x upon the percentage change in the price of the same commodity x. So how the demand is going to respond, what is the percentage change in the demand in case if there is a percentage change in the price. For example, if there is a 1% change in the price, what is the percentage change in the quantity demanded? So own price elasticity of demand, I should write it like what, EP is the percentage change in quantity demanded of x whole upon percentage change in price, right? So what is that? Price of x. So it is del x by del px into px by x, right? Well, you have already calculated beta. X star is m upon 2px. What is del x by del px? Right, it will be minus m upon 2px squared. So it is minus m upon 2px squared into px upon x star. What is x star? You've just calculated already, m upon 2px. So 1px is cancelled out with this. So this is basically m upon 2px upon m upon 2px. That's what it is. So that entire thing is going to get cancelled and you will have just minus 1 out here. So here for this particular function, the kind of the demand function which you have got, it means this. So in case if there is a 1% increase in the price for x, there is going to be the 1% decrease in the quantity demanded for x. What is income elasticity of demand? So it is E, not EY. We should be rather writing EM, let's say. So it is percentage change in quantity demanded of X whole upon percentage change in income. That's what it is. So if there is a 1% increase in income, let's say, income elasticity of demand is going to tell you what is going to be the percentage change in this guy, quantity demanded for X. So, well, mind you, I mean, this elasticity is a unitary measure. So what do you have is this thing. So your X star is M upon 2P1. Del X star by del M is 1 upon 2P1, right? EM is del X star upon M upon M by X star. So it is 1 by 2P1, 1 by 2P1 into M upon 2P1. That's what it is. Where should I write this? M upon 2P1. So everything is going to get cancelled out. Going to be 1. So it means that in case if there is a 1% increase in income, then the kind of utility function which we have and the demand function which we have got, there's going to be the 1% rise in the quantity demanded for X. And then at last you have the cross price elasticity of demand. So EXY percentage change in quantity demanded of X whole upon percentage change in price of Y. So how do you go about this? So it is del X by del Py into Py by X. So basically what you're trying to say is this, that is, in case if the price of the commodity Y is going to increase in the percentage terms, let's say, what is the percentage change in the quantity demanded for X? So the expression is this, del X by del Py on this guy. So in this case, your EXY is going to be what? Del X by del Py. So guys, sorry, X star was M by 2Px. So del X star by del Py is going to be equal to 0. So it will be 0 into Py upon X star. You can just write it. It doesn't matter because you're ultimately going to get 0 only, right? So in this case, your cross price elasticity of demand is going to come out to be 0, right? The goods are not related with each other. So this is what you have done for one utility function. Now the reference for this could be the several chapters of area. They're going along. We'll pick up the new utility function tomorrow and we'll try to see how the things are going to function in this. So you have these are the basic things. So you should be knowing all this. So this is useful for people who are preparing for their semester exams or who are preparing for the MA Economics entrance or anywhere, I mean, where Varian or Nicholson or these books are generally used, whichever. I mean, the intermediate micro course will have these things. Okay, thank you, Vita.